discuss to you about the derivative of the basic trigonometric functions. Then this will be followed by an example that is finding the derivative of the sine function. And after that, we're going to show to you the proof of the derivative of the sine function. Okay? Okay, let's start with the first formula. We have the derivative of sine x is equal to cosine x. The second one is the derivative of cosine x, which is equal to the negative of sine x. Then the derivative of tangent x is equal to secant squared x. And the fourth one, we have the derivative of cosecant x is equal to the negative of cosecant x times cotangent x. Then the derivative of secant x is equal to secant x times tangent x. Then the derivative of cotangent x is equal to the negative of cosecant squared x. So these are the derivative of basic trigonometric functions. Now, all we have to do is to familiarize all these formulas. Now, in order to familiarize, in order to learn mathematics, we have to do mathematics. So, as an example, we have to show that the derivative of sine x is equal to cosine x. How do we do this? First, we have to recall the definition of derivative. If we are given the function f, then we can use the notation f prime of x, which is equal to the limit of f of x plus h minus f of x over h as h approaches 0. So here we have to identify what is our f. Now since we are asked to find the derivative of sine x, therefore our f here is sine x. So that's why the derivative of sine x, we have the limit of sine of x plus h minus sine x over h as h approaches 0, because sine x is our function. So simplifying this one, we can now use the trigonometric identity. So what's the equivalent of sine of x plus h? This is equal to sine x times cosine h plus cosine x times sine h minus sine x. Simplifying this whole expression, we have the limit of sine x times quantity cosine h minus 1. Actually, this is from sine x cosine h minus sine x. The minus sine x here is actually the sine x in the previous expression, in the last part, plus cosine x sine h over h as h approaches 0. So, simplifying again, so from here, we can rewrite that one into this whole expression. So we can write, instead of putting sine x here, we can also put sine x in this side and also cosine x in this side. So the two are equivalent. Okay, take note of that. Next, okay, now we have sine x, this expression here, okay? In the previous expression, we have cosine h minus 1, but we can also rewrite that one into this expression by putting negative sign in the side. So this is still the same. Now, why we do this? We do this because we can use the conjugate of 1 minus cosine h to come up with another equivalent, okay, using another trigonometric identity. So simplifying this one, by multiplying its conjugate, we have 1 plus cosine h over 1 plus cosine h. Okay, 1 plus cosine x times the limit of sine h over h as h approaches 0. Now, this expression here, if we are going to multiply, this is equal to 1 minus cosine squared h. Then h times this one is equal to h times quantity 1 plus cosine h. Okay? Now, we have to take note that there is another equivalent of 1 minus cosine squared h using the trigonometric identity, and that is equal to sine squared h. Sine squared h. So we have the negative sine x times the limit of this whole expression plus cosine x. Now, in the previous expression, we have limit of sine h over h, which is equal to 1. So we put 1 here. And moving on, take note that this sine squared h over h times 1 plus cosine h, this can be written as sine h over h times sine h over 1 plus cosine h plus cosine x times 1. Okay? Now, this one is very obvious. This is equal to 1. So, simplifying that one, we have this one. So we have negative sine x times 1 because the equivalent of sine h over h as h approaches 0 is 1. Then this is the limit of sine h over 1 plus cosine h as h approaches 0, 1 plus cosine x. Okay, so we have to evaluate the limit of this expression. Now as h approaches 0, so sine of 0 is 0 over 1 plus cosine of 0. Cosine of 0 is 1, so 1 plus 1 is 2. But the numerator is 0 over 2, so the whole expression will be 0. So we have negative sine x times 1, which is negative sine x, times 0 is equal to 0. So this whole expression here is 0 plus cosine x. So therefore, we have cosine x. So we have shown that the derivative of sine x is equal to cosine x. Okay? So this is our proof of the derivative of sine x, which is really equal to cosine x. Okay? So thank you so much for watching, and keep sharing the learning that you've got from this video. Thank you and God bless.